So we're going to do a different example here. So we're going to consider the search problem once again. So we're going to consider given an array and a key X. I would like to find where that key X is in the array A. If it doesn't exist, I want to return -1. So I'm going to present another variant of linear search to you. This one, some people might be familiar with some flavor of this. But most certainly we're going to have to be a bit more careful this time. But I would say it's still not too bad. So let's consider the following algorithm. We're going to call it OutsideInSearch. So it's going to be given an array of length n with key X. As input, again, I'm not going to include the output, even though I usually do, just because I don't know if it's correct or incorrect. If you want to put that for the sake of completeness, just say it returns an integer, because we don't know if it's actually correct or incorrect yet. So it's an array A of size n, and it gives you a value or key X. So what I'm going to do is, instead of having it where we sweep from left to right, as the name of my algorithm here proposes, it's going to go from outside in, okay? So what we're going to do is we're going to have two fingers. We're going to have a forward one and a backward one, where what's going to happen is they're going to move closer and closer and closer to the middle. So we're going to have 2 pointers. They're just going to be, well, they're not necessarily have to be pointers in the programming sense. They're just fingers that I'm going to have that tell me where to look. We're going to sweep them from the leftmost side and the rightmost side, and they're going to go inwards. So let's see if I have any mistakes in this algorithm. So we're going to have two variables. L is going to be the leftmost one, the leftmost finger. So the finger is just something to help me keep track of where we're looking, okay? That's all. That's why I'm calling it a finger. It's just like if I put my finger on the position in the array. It's help me keep track of where things are. So we're going to have a while loop this time. It's going to ask, it's while L is less than the floor of n over 2, which I'll describe what the floor is in a moment, or that U is greater than the floor of n over 2. Do the following. So for those that aren't acquainted with the concept of the floor function, what it means is you take or strip off the fractional part of a number. So if you have a floating point number, strip it off. So for example, if I have 2.5, the floor of this is just 2. If it's 2.999 like this, that's just 2 as well. It's always round down, round out. It's just the rule is to always round down. So I must stress that the of 2 is just 2, because there's nothing to round here. It's just an integer, right? So what I'm saying is, if you divide by 2, I want you just to strip off any like 0.5s or anything like that, okay? The decimal part. So if it is the case that L is, it's got to be that one of these two conditions holds, because it's an or. So it's either, so it's one of this could be true, that could be true, or both of them could be true, but this loop is going to finish when neither of these is true, meaning they're both false. So while it is the case that these two or one of the two is in place, we're going to check if U is greater than n over the floor of n over 2, and we check A sub U is equal to X. Then we're going to return U, because we're going to evaluate that position. If L is less than n over 2 with the floor, and we check the left finger's contents. So we check the contents at that finger, the leftmost one. If that equals X, then we're going to return L. And then we're going to just move our fingers inwards. Just going to go like this. So L is going to be incremented by 1. u is going to be decremented by 1. And when this process is finished, we're going to return -1. If it does not return anywhere in this while loop. So anyways, let me walk you through this again. So let me, let's get a picture to help us with this. You can use an array of length 4. And suppose that x is equal to 2. So we're going to try to find 2 in the following array. 5, 2, 3, and 4. So what I need to do now is I want to walk you through this process of how this would work. So I start off with L and U, these fingers. They're going to be pointing, they're going to be kind of both at those spots on the ends. We check these conditions. Now remember, the floor of n over 2 in this case, because it's of length 4, 4 over 2, remember this is a clean division because it's even, right? 4 over 2 is just 2. So these are going to move inwards, but it's going to keep it working its way until long as L is less than n over 2 at the floor, or U is greater than n over 2. So it could be one or the other at least one of these two has to be true. That's the point I'm getting at. So let's start off this. Let's see. So we check if U is greater than this. Yes, it is, because it's 3. 3 is greater than 2, but it's not equal, so we don't return. If you remember, an AND means that both these conditions have to be true. And I must stress as well that we're also evaluating this first before we evaluate that. So I'm not picking on a spot where it just simply doesn't exist. Here it doesn't matter too much, but it's something worth noting. We're doing short circuiting for those that are knowledgeable of that concept. So likewise, I check if L is less than n over 2 at the floor. Yeah, it is. 0 is less than 2. But it's not equal to x. So what we're going to do is we're going to push in L and U. So L is now going to be at position 1. U is going to be at position 2. Now, let's go through another iteration of the loop. So while L is less than n over 2 at the floor, it still is. 1 is less than 2. So this condition is being satisfied. However, notice that now U is 2, so this condition is not being satisfied. However, at least one of the two is being satisfied, so we proceed inside the loop for the next iteration. We know this one's not going to be validated, so we go to this one next. We check this, and notice that, yeah, position 1, so notice that this is still less than n over 2, so because 1's less than 2, but notice that now A sub L is equal to x, and so it returns this position. So in this case, it does find the solution, which is position 1, right? It tells me where it is. So, what's wrong with this thing? Now I want you to stare at this before you get too convinced that this isn't right, because there's a lot of elements about what I just described to you in words that may not be necessarily translating here to the algorithm's description, which could be a very simple mistake somebody can make. So remember the simple tips I have. 1, make sure you understand the algorithm, because that's going to help you a lot. 2, you want to outsmart the algorithm. If you believe there's a problem with it, present at least one counterexample. If you can, ideally, present a set of counterexamples, because it can tell you a lot more about what's going on with it that you can fix, or at least attempt to fix, if you can. So let's think about this. It has to be that both these conditions are satisfied. What if I just did something very simple like this? So in this case, if I make the key 3, the solution needs to be 2 in this case. It needs to be position 2. Do you see how this might cause some problems, right? Let's take a look here. Let's continue with the execution of the algorithm, now with this setting in place. So imagine L and U are in these same spots as we had before, except now, instead of it being that it finished here, it says, hey, look, that A sub L is not equal to x yet. So it proceeds to the next iteration by moving L and U. So it proceeds, moves L and U. So L becomes 2, U becomes 1. But now you look at this and say, okay, well, is L less than the floor of n over 2? The answer is no, it's not anymore. It's because it's equal to the floor of n over 2. So it will not go and proceed to the next iteration of this loop. The problem we have with our algorithm, at least if this counterexample makes sense, because notice that in this case, notice it's going to return -1 as opposed to it being returning 2, which is what you should expect. What's the problem? What's the fundamental problem with this algorithm as it's presented to you? The idea of sweeping from the outsides to the insides like this, there's nothing wrong with that idea, but there's a mistake in the way I've described this algorithm to you. Do you see it? Yeah. You notice that. So the element at the floor of n over 2 is not examined. That's the mistake. So the way to resolve this issue, and I must stress that you can create counterexamples just like this one. Again, just put it. So all you do is create an array, an arbitrary array of length n, and what you do is you place x right at the position of the floor of n over 2, and that can guarantee you that you're not going to find it. So it seems like the way you would fix this issue with this algorithm, for example, because that's one piece of the advice I'm giving you here. If there's a mistake, it could be that the concept still makes sense, but there might be an issue with the algorithm in the way I described it to you like this. So what I was going to make as a suggestion for you to fix this algorithm, and I'll leave this as an exercise, is make it so either L or U is allowed to check the floor of n over 2 as a position.